I think the worst is the ebb and flow. I'm recording now, by the way. So let's go ahead and
Okay.
start the game. And so, Zach, did you want to explain what's going on here? Because I've shown this game to other people at this point, and a lot of them don't know what this is.
Okay,
They can kind of guess the fire.
yeah. So the red squares represent fire spreading across the grasslands, and the green tiles represent the grasslands. The grasslands also have nice little reservoirs of water in them that are created that help protect all of the villagers that live there from the fire. So the little gray squares that are running around on the screen, not now, but when they are running around in a second, hopefully.
It may have gotten stuck. This happens occasionally. I don't know why, but let's go ahead and restart.
Okay, yeah, so those little guys are all gonna die. Because the little brown squares are their villages, and if the fire burns down all the villages, then you lose. The only way that you're able to defend the villages are by swapping the tiles of grass with the tiles of water, and that blocks the flow of the fire. I think that just about covers it.
We're already at wave 4. Did you see that?
Very deep, complex metagame.
Yeah. There is
really quite difficult.
There is some bug that we're not gonna fix, but there's a bug where it doesn't progress, and then I see that the waves just increment by 3 or something like that, and then it just freezes. I don't know what's going on, but
great.
That's always fun. But fun to demo at the very beginning of something. It's just a bug that you're hoping wouldn't show up. But yeah. Anyways, so yeah, that's just this. Like Zach said, it's a simple version of the game. Oh, I mean, sorry, details of the game, and see, it just increments. This is something that was never fixed, although I thought it was working until now. Anyways, so that's the inevitable heat death of the universe, and now we're gonna get into the implementation. And oh, look, there's some
nice
destroy immediate
good
errors because we're not checking for null somewhere or whatever. I don't know, but that's the gist of it. So one thing, Zach, I was wondering if we should show or not is like the Unity setup, but also I don't know where should we begin. The grid, or
I think what might be helpful is to just walk through the main flow of the actual game before the main flow of the game's objects and code. So note to the viewers, the viewer, my mom, the grid page object does not have any tiles or anything underneath it, so we all generate it on the fly at runtime.
Yeah, so we have a couple game objects here for the menus, the canvases and stuff, but then we have the game over screens. The windscreen actually is never used. That should have been deleted, but whatever.
That's okay.
The grid stage is the main game object that we're using here to hold references to many of the game objects in the scene.
Yep.
And so we're toggling the audio and the game over screens.
The other ones are just prefabs, though, too.
Yeah, the tile and the villager are prefabs that we're using to clone or instantiate a bunch of these objects in the scene. And so if I wish I could toggle the audio off as soon as I play it. I don't want to maximize it either. I think I can toggle it somewhere. All right, so let's go ahead and accept my fate, and then we see here that the grid, it's defining code, which we'll show in a second. There's 12 by 12 tiles, and these tiles are actually it's a prefab here that we're just coloring. They start off gray, and then we color them with a certain color. And the colors are based on a couple of different thresholds. So one thing that I put in my notes for this game, because Zach and I had a little bit different goals for this project, and Zach started out with, he started the code for this game, and it was mostly the tile code.
Mm-hmm.
And I was doing some stuff beforehand, just learning how Perlin noise works. I still don't understand 100% how it works, but I know how to use it now. But that was my main goal, was just to learn how people are using this and how it generally works and what the theory behind it is. And then seeing how Unity actually already has a function for that, made me think, okay, well, if we're going to make this tile game thing, we can just use the Unity function for it, and then it returns values, and then we can just use those values and then a couple thresholds that we set to make these different tiles. And then maybe we can turn that into a game. So it came from me wanting to use Berlin noise to generate at first a map, and then it became, okay, how do we take that map and turn that into a game? And I really like the way that Minecraft does that, and everyone uses Minecraft as a reference point. But I think it's cool how Minecraft's interesting because it's kind of dynamic in the sense that it generates it, and then it's active afterwards. But also, as you're playing the game, and then you move to the extremities of the map. It's procedurally generating new content, which is really neat, because most procedural generated things, games and such, they don't really do that. They typically generate stuff from the get-go, and then you just live in that box. And that's how Minecraft was in the first version. Which is kind of what happens here too. Like we procedurally generate this wave, and then the next wave uses a different seed in a different location on the function, on the gradient. And then it just uses that to generate its values here. And then Zach, you basically made the whole swapping and the tile placement stuff.
Yeah.
And then you were just kind of along for the ride with my weird idea. So we didn't really have. That's one thing I put in my notes too. So we didn't really have a clear vision of what the game was going to be. We just wanted to learn and try things out. I think you had more of an idea than I did in the beginning, and then we both didn't have an idea of what it was at the end.
Yeah, I think the thing that I learned from this is I like to consider myself a good game designer, but I actually have literally no evidence to support that, because I haven't made any games. So I don't know why I believe that, but talking to Patrick and getting ideas out of my actual head and out into real space and thinking about it and realizing that those ideas actually aren't fun was something that is really important. I think that that I learned from this, and it's really good. It's a really good idea to start prototyping as fast as possible. And honestly, I don't think that at any point of our implementation did we actually fulfill a prototype for a design fully. We only made it about halfway and then decided that the design wasn't good enough. What I would say that I would want to do the next time, do a lot more planning and have a better vision of what the game will be, even if it's still pretty brief. It doesn't have to be a Breath of the Wild-esque idea with all of the details that come with that. But if it's just some core tenets for the game, design, and then figuring out how to implement that later, I think that will make a game that's a lot more cohesive and fun than this, which feels kind of just like a senior project in college of we learned how to code a game and that was it.
But let's get into the code now, because we're talking, and then we can get more at the end into why, or what we want to make next.
Yeah.
So.
Yeah, let's just start with the grid stage.
Sure. Yeah, and do you want to explain a little bit? Is this big enough for you? Can you see this?
Yeah, I can read it fine.
Great. Okay. So, I mean, if I scroll up here a little bit, you can see. Oh, I'm actually in the tile class right now. So we have 3 classes. They're not the tile and the villager class are not big at all. These are the scripts that are actually attached to the prefabs, which become game objects in the scene. But grid stage is the game manager. I hate that term, but
Yeah.
and it's big. It's bigger than the other ones. Honestly, this game is really small though. Um,
Yeah, it's a really simple, small game.
yeah, and I think it's because there's just a lot of generating happening.
Yeah.
There's a bunch of messy like getters and setters up here, but whatever. Let's go ahead and start. So
Yeah, actually, you
yeah, let me go ahead and
wrote the
explain
majority
that.
of this code, so you should just start.
Sure. There's some messy code here that basically toggles the menu on and off. There's some references to the game objects in the scene. Not very interesting, but main menu visible toggles it off or on. There's way better API um, interfaces for doing this, but I don't really know what I'm doing in Unity, so I just decided to call it main menu visible false, which doesn't really make any sense. You should probably have two methods, hide and show, but whatever. So restart game is the main thing. This also should have had a cleaner name, but restart game essentially is invoked on a new wave. And so restart game first happens. I think it's in start. Yeah, restart games happens when the game starts. Because start game is called an init, I think, somewhere, or not an init, in start. Main menu visible, game audio play, somewhere. It happens somewhere. Oh no! I'm sorry. The main menu has a button, and the button has an on-click listener, which does start game. And so restart game restart game is called. Cleanup is then true, and if it's cleanup, then say you already had a game running, it'll go ahead and clean up a bunch of these references. It'll stop the fire from updating. So there's a coroutine that does the fire updating, and so there's an existing one that it clears. The last click tile is for the selected tile. It holds a reference to that. The villager tiles, the village tiles. This is kind of interesting because this used to be the way that we calculated the win for the game. But so this is actually kind of redundant, I think, but whatever. So generate grid is the part that is the most interesting to me. And then also this kind of loop here is weird. So it's possible with Perlin noise. I think I should probably show that right after this just to give some context if people don't even know what Perlin noise is. But generate grid, what it does is it goes through and then it takes a tile and it takes the tile coordinate, say 0, 0, then 0, 1, 0, 2. It goes and then it adds a multiplier, a scalar value, and then it gets a coordinate or just a value from the Perlin noise function. And then whatever that value is, if it's in a certain threshold or gradient or domain, then it assigns it to a tile type. And what's interesting about this is if two tiles are next to each other, close enough to each other, then they're more than likely going to be the same. But those values are determined by the Perlin noise function, so you have clumps of tiles together that are the same type, which is kind of cool. But anyways, there's a such thing as a valid game in our game, and it's possible that when you're generating a grid, you won't have a village tile, which we need. It's possible that you won't have fire tiles, which you need. So valid game, if I go down to wherever valid game is, I think I could have clicked into that, but valid game basically goes through the entire grid and it says, have we found a village? Have we found fire? And then it says, it's only valid if we found village and we found fire. So we go up here, and if it's not a valid game, then we go ahead and restart this entire function again. We just call the function again. It's recursive. And then it goes through and it cleans it up again. And it's kind of wasteful. There's probably better ways to do this, but I knew this would work, and so I just went ahead and did this. Cleanup means basically a new game. There should have been a new game, not cleanup, but whatever. If it's a new game, then it generates the villagers. If it's not a new game, what happens is restart game will have cleanup be false, and the villagers will not be regenerated, which means that on every wave you'll have less and less villagers. Right now, there's some bug, there's some null reference actually not causing the next wave function to break, but whatever. So in tile, where is Perlin noise? Right here. So init type, when tile is created, there's a position set, there's a tag set. Not really, the tags we're not even using anymore. Actually, we kind of are for selecting. The type is initted by the seed. So the grid stage, it creates these tiles, and then it passes in a seed, which I'll show in a second. Actually, maybe I should show that now. So if I go to grid stage, and then in the generate grid method down here. So back to what I was saying, the generate grid function here, it goes through all the tiles and then it deletes all of the tiles, assuming this is a new game or a new wave. And so these will exist when generate grid is called. Actually, they might not. It doesn't really matter because tiles is going to be an array. It's either an empty array or not. So seed, yeah, I mean, so seed is 1 to 100. It's just an integer, and so that is passed to create tile down here. So this is just a nested for loop. It's going through the 2D array grid, which we have defined above. It creates a bunch of tiles and it passes it its position, and then the pointer, which is like the current tile. It's just the I mean, it's pretty self-explanatory. Create tile, I just showed that it inits the tile with the seed and the position, and then we track certain tiles for game state because we want to know if the village tiles or the grass tiles are, if the village tiles, there are no more village tiles and they're all burnt, or if there's no more grass tiles, then we know that the fire's not spreading anymore and we need to either end the game, or actually if the fire's not spreading anymore, we move it on the next wave. So tile inside of init, we see that the type is initted through the seed, and right here it takes the seed and it passes that in along with its position to the this is just it's a value that we just picked out of nowhere, out of thin air. We just kind of goofed with the scale value there for the position. I think there are some references online saying that you should use 0.25 or something like that, or 0.15. I'm not really sure what the scalar value there, that it's a magic number that you add the seed to or whatever. I'm not really sure, but the Perlin noise function in Unity is actually a 2D Perlin noise. So you can have ND Perlin noise. But the seed, it just basically goes to a different coordinate plane inside of the Perlin noise function. It just picks the gradient, essentially. So you can think of that like being 0, 0. Then if you add a seed that's 100 and 100, you're working on an entirely different location on that function. So that's what that means. And then based on whatever the value there that's returned from that, you can think of it as like peaks and valleys. So it's either going to be a really high value or it's going to be a low value. And based on those high values and low values, we set them to certain tile types. And so low values are actually what we're saying are peaks, and then the high values we're saying that they're not, or vice versa. It doesn't really matter, but these high values we are assigning to villages, and then the low values we're assigning to fire. And then there's something. I gotta analyze this again to understand how we're setting these values.
I like that comment that says 10%, and then it's actually 5%.
It's actually 5%. Yeah, this used to be 10%, and then I changed it a little bit because there were too many villages spawning, and I never updated the comment. Yeah, comments are confusing. Don't trust comments.
So basically, I think what would be a simple way to explain this is it's kind of an artifact from our original design, which we wanted to create a two-dimensional landscape, if you will, with each tile corresponding to a different height. Um, so if you were to think of a mountain range, it's basically looking straight down at the mountain range, and our original design was we would scramble up all the peaks and all of the valleys in that range, and then the player would have to swap the tiles around to basically create a mountain pass that would be easiest for them to traverse across the grid. But then we decided that was stupid. And so we ended
Yeah.
up doing, well, maybe not stupid, but it wasn't very well implemented in the resolution that we had. The constraint of a 12 by 12 grid was too small for that elevation to be very clear. Um, so we still use this elevation term, even though the fire and the water and the grass are not actually tied to any specific like literal elevation in the game. But that was a transformation from us going from mountains to, okay, well, there's going to be lakes in the valleys and there's going to be lava coming out of the top of the mountains. And then we just scrapped the mountain idea. And now we're just thinking about it as a completely flat area. Um, but we still use elevation to determine the regions of of a value from 0 to 1 um, that we pick for specific types.
Yeah, actually, yeah, exactly. And the resolution part is really important. But I think we went from okay, if the resolution is the problem, then why don't we just scale that up? And then we realized, holy crap, okay, if it's really big and the resolution is really high, then or large, then we have to swapping one tile at a time is not going to work.
Yeah.
And then also, it's really difficult to see how. So the resolution is really low. Then being able to see how one tile is different from another when you're zooming in super far on the Perlin noise function.
Yeah.
Everything looks the same and looks really muddled. And then, but if you zoom out, then everything looks completely different. So you have to kind of hit a sweet spot. And yeah, it was not easy. Like we tried, if you remember, we tried to make the peak of a mountain have something on it and be a little bit different, and then have like the water be in the valleys.
Yeah.
And so it looked like a top-down map.
Yeah.
And then we were trying to figure out, okay, could we add like water physics and stuff? And it was so hard to tell what was higher than what.
Yeah.
Because the resolution was so low.
Yeah. And we had no better way of visualizing it than darker values and lighter values for the colors. And so we ended up with a grayscale grid. And
it was really weird.
Ugly and didn't really communicate what needed to be communicated. So we scrapped the idea of elevation, but that still exists in the code base. So if you look at the actual blocks of code there, it's spawning a fire tile. If the elevation is, unfortunately, the elevation also is swapped because of the way that we were calculating the color of the tiles. So it's also something that's kind of stupid that we should change, or we could change now to make it more clear. But basically, 0 is the highest point and 1 is the lowest point. And so if you look at the blocks, it says that if the elevation is above 0.15 and like basically very high, then we spawn fire or lava in the case of mountains. And then if it's very low, meaning below 6 or 0.6, then we give it water. And then somewhere in between there, we're spawning some villages 5% of the time. And so it's a little bit clearer to think about it spatially. But unfortunately, all of the extra complications of flipping the 0 to 1 range to like mean lower when intuitively 0 should be the lowest value and that sort of stuff.
Yeah, and it doesn't matter either. Like we could have made it higher or lower. Yeah, and then also this is really confusing. Like you pointed out that it's these values are between. If you read it, then it makes sense. But
Yeah.
Because you don't want to be having so you could reduce this window and then have villages spawning, or you could do something weird like this and then say, okay, well, these are going to be grass tiles except for 10 or 5% of the time.
Yeah.
Which is kind of weird, but that's one way that you could have done it. Or you could just reduce the window.
Yeah.
Because again, all of the Perlin noise function is doing is you're giving it values that are going to X and Y values that map to the function, and then the function is going to return the Z value. And so you use that Z value. It's 0 to 1. It's a floating point value. And then you use that value to calculate whatever you want. And so first we were doing elevation, and then it determines like the opacity of the tile. But then we decided to say, okay, well, if it's in this certain window, now it's going to be a certain type. And that shows you like the frequency, as well as making grouping tiles together correctly and neatly. So moving on from creating knitting the type, as soon as we have a type on the tile, we can render the tile. And all our render tile is super simple. All it does is take the game object that's associated with the script, and then there's a little bit fancy stuff that says if it's selected, then set the color to this kind of light gray color. But if it's not selected, then go ahead and set it to its type. And so it's really simple. I mean, it's very obvious what's happening here. If it's fire, then it sets it to this red color. And what's funny, as I just noticed, Zach, is this opacity is redundant. This is an artifact, I think.
Yeah, that's great.
There's a lot of stuff here that we should have deleted, but whatever. Well. Yeah, opacity is not even being used, so ignore that. As you see down here, they're not even being used. And it had to do with selection, but it's not being used. So
I think probably the next, like the meatiest part of the code would probably be the villager running around, and then the grid stage remainder, because a lot of actually
the grid stage updating is a little bit hairy.
Yeah, actually that's a good So
but we can show let's do the tile updates, the fire updates, and then I'll show you then we'll show the villager, then Zach will take over with that.
Yeah, that's good. I like that.
So let's go back to grid stage here, and we see that there is in the beginning of the game, I think it's generate game or generate grid. I think it's generate grid. If we come down here, go to the bottom, maybe it's not generate grid. Create tile, next wave, start game, generate villagers, restart game. There's a subroutine that is started. Where is it? Stop coroutine. There we go. Start coroutine. So this is arbitrary. We don't need to have this value. What matters is here. So what's happening here is there's a function update tiles that we have that's returning an I enumerator. Start coroutine takes this as a parameter, and it starts this as a thread. So update tiles down here. If we go down here, update tiles. All it's doing is it's going through all of the tile references, and then for every tile reference, right here, for every tile reference, it's saying, okay, who are my neighbors, and based on who my neighbors are, what should I turn into? And so update tile is in the tile class, and it's doing that logic. And then of course we have a few catch things here, which say, okay, if we update and then there was fire around us, we should burn, so that this current tile is now going to be a burn village. And we say, okay, these village tiles have one less village because one of them's burnt. So we're going to go ahead and remove that burnt village from the village tiles. And same thing with the fire here. We're going to remove that grass tile from the fire because grass tiles, the grass tile caught on fire. So, and it's either or. So, and then right here too, it does some checks to see based on the village tiles and the grass tiles, or the alive villager count. Actually, I think, Zach, this is another artifact too. So the grass tiles, actually, there's no calculation. Oh no, there is fire spreading.
Yeah.
This code is really messy.
Yeah, I mean, we were working fast.
Yeah, we're working really fast. We're just trying to get things moving. But fire is spreading is another getter method that's kind of we weren't consistent with that, but I
That
kept.
casing drives me nuts.
Sorry.
That casing drives me nuts.
I know, but it's something that Unity complains about, which is annoying.
That's dumb.
Or not Unity, sorry, C Sharp. So yeah, this is fire is spreading is a Boolean bool value, and it's calculated based on the villager count and the grass tile count based on where it was from the previous wave. So it says if there's no villagers anymore, if none of them are alive, then it's game over. Otherwise, if the fire is not spreading anymore, meaning it's hit its edges and it can't go any further, then we're moving on to the next wave. And then this one is if we're not game over, if we're not moving on to the next wave, then we're still playing the game. So we should update the tiles again. So then it just calls itself and it goes through this whole loop again. There's some complexity with the swapping tiles. Essentially, all we're doing is just holding the last click tile in memory, and then if another tile is selected and we have a click tile defined, then when we swap the position, and it's actually quite simple. We're just switching them around and then changing the game objects transform positions mutually. And then we have this not factory function, but this helper function inside of the tile class, which sets position because we have grid references. So that's the confusing part about this. This type of game is that we're generating these tiles in a grid that is both in game space and in logical space. So we have a grid that is 12 by 12. If we go up here, we have a grid that's 12 by 12. But we also have a game that is whatever the tile width is. I think it's like 65 times 12 by 65 times 12. So we have to map those tile widths, or where the game objects are, somehow to a grid logical space. So what we ended up doing is just having these grid positions. So if I go back to tile, we have a grid X and we have a grid Y. And that's just how it is. And we have to keep references to those both. So we have a reference to a game object, which we can manipulate its actual physical space. Then we have the X that makes sense in the logical grid. And then this is the update tile method that I was talking about that just checks the left tile, right tile, top tile, and bottom tile types. And then it checks if they're flammable or not. And then it catches itself on fire if one of them is or it checks it if itself is flammable, and then if one of the surrounding tiles is fire, then it catches fire. It catches fire and just does all this stuff.
Oh, that whole block.
What about it?
Ouchie. Just that could be simplified a lot.
Yeah, it could. It was a lot worse before, though.
But no, there's a lot of things in here that we both wrote that are great.
Yeah, this could be like or, and then one method to catch fire instead of 5.
Yeah, that's okay though.
Whatever.
I think maybe one thing that you might want to briefly share about is the grid snapshot in the update tiles, because
I think I passed over that, didn't I? I thought about talking about it, but that's a good point. So one thing that's interesting about the way that we're doing these tile updates is you have to. So we're doing a traverse of the grid once, and then we're doing it again. And the reason that we have to do that is because we want the grid to update at once, per se. If you don't do this loop here, then the game is going to update sequentially. And the problem with that is that so if I update, say if we're moving left to right down the tile rows, so for 0, 0, 0, 1, if 0, 1 is fire and 0, 2 is a village, then as soon as we get to 0, 1, it's going to be dead on the first update. It's kind of strange to think about, but it's very obvious when you see it. So the first tick, the fire will completely cover the map, because you're changing the state of the previous tiles as you're iterating through the updates on the grid. And so what you need to do is you need to get the previous state. So a snapshot is what we're calling it, a previous snapshot from the grid, and then use that as reference for every tile update. It's kind of weird, but it makes sense. So it's kind of weird, but when you see it in action, it makes sense because you have to take a snapshot of all the tile types and then hand that to the update tile method. So it uses that instead of it like the previous tiles.
Yeah, if I understand correctly, this only happens when fire can propagate downward and rightward. But if it were to propagate leftward, you wouldn't have the same problem.
Exactly. So if you're swapping tiles,
bottom right,
yeah,
then it would update the way that we would expect it to. But as soon as it can travel to the right or down, because we're iterating right and down, it would just carry that fire every single time it iterated across the tile. It would carry it along with it on every update, unless we took a snapshot of it from the very outset.
Exactly. So yeah, if the fire started, if it generated in the bottom right, then it would update as normal. But if it was anywhere in the left upper region or anything any further, anything below and to the right of it, of the fire tile, will catch on fire immediately, which is not what we want. We want it to be more even and update at once. So that's why we had to do this weird extra nested for loop to get the grid snapshot. There's probably smarter ways of doing this, I think, but this, I don't know, this made sense, and we didn't want to spend that much time thinking about it.
I think it makes sense.
Yeah, that for if statements down here, really, they make me mad now when I see those.
That's okay. Lastly, we can talk about the villager stuff, right?
Yeah, I think that's it. I think the last thing I didn't talk about was the selection. So the select tile. Oh no, I already talked about that, didn't I? Yeah, I already talked about that.
Yeah.
Okay. Yeah, let's go over to the villager class now. Scroll all the way up. Let's go to the villager. All right, there you
go. Trying to remember what I did. Oh, so basically this is the one thing that I don't understand super well, but I figured it out along the way. Was basically what we wanted to do was have the villagers be unsafe on the grass and be safe in the water, but we also didn't want it to be as simple as keeping the villagers in the water or something like that. So the design was that they can run as fast as they can on the grass, but then they have to swim when they get through the water, so they're safe from the fire, but they move slower, and so there's less of the likelihood that they will make it to a village in time. So what I needed to do was add a way to detect if the villager was on fire or if they were swimming, or if they had made it to a village. So the main thing that I did was find the nearest village and target that, and have each villager be able to run to the closest village to them, as well as being able to detect what tile they were stepping on. So there are two main things in the update function. So there's a physics2d.overlap box that basically casts a box in the same space as the villager, and we have colliders on each tile to determine what tile type they are on, if that makes sense. So the overlap box will return an object that collides with the box that casts, if that makes sense. And in our case, since the only colliders were on the tiles, it would just get any tile that is the closest to the villager or that overlaps the most with the villager, which is kind of wonky with the fire. Sometimes they can be on fire when they're not actually being touched by it, or they can be in the water when the fire is actually touching them or something like that. So the colliders aren't perfect, and they should definitely be improved, but I will not do that because it's extra work for nothing. So the colliding object will basically tell us the type, and then we will change the speed of the villager or kill them instantly if they have touched the fire. I forgot what I named that function until just now, but it's great. Thanks, Mom, for watching this video. So, and then it's really quite a simple calculation to figure out what the nearest village is. I just have a list of village tiles, and I use the link functions to get the ones that are non-null, and then I ordered them by a distance calculation. So I basically sorted them by the distance between their position and the villager's position, and then returned the very first one or the very closest one in that list. Um, and then it's a really simple step function to move them frame by frame toward that village. And yeah, and then once they die, then they are no longer calculating the closest village and moving, so they stop in place and they turn black because they're burnt. So that's it.
Very good turn. So,
Can you please do some air horns? Edit in some air
pew,
horns.
pew, pew. I can do my
Great.
mouth. I don't want to edit. I'm just gonna do my mouth.
Okay.
So, so I guess we can talk about next steps and what we would do to improve this game if we wanted to finish this and make it nice.
Yeah.
Because I mean, it's pretty. Relatively, this game is very simple.
It's extremely simple.
It's so messy for how simple it is.
Yeah.
But so what would you want to get if you were doing this again? How would you make this game better? And then after we both say that, maybe we can say what we want to do next or what we'd like to tackle next.
I think what would be most helpful to help structure the code and for our working space sake would be to modularize the code a lot more. And I'm struggling to figure out actually how to do that because I don't know Unity best practices, but I do feel like there should be either objects, managers, if you will, that focus on different layers of the game. So there might be one that handles menus. There might be one that handles rendering within the game. There might be one that handles the core logic of the game, like the abstract logic that would maybe contain the actual grid, the villager, like computation of where they're going to be running, the fire spreading, that sort of stuff across the grid. And there's another object that's dealing with the rendering of all of that has an instance of the grid itself. And then the win conditions and the menus and that sort of stuff would be maybe stored in another one. The main problem that we had, I think, was, or at least I spent a lot of time kind of twiddling my thumbs and trying to figure out what I could do next and just drafting ideas in my head. Because since we did only have one main class, the grid stage class, and we're using the Unity project version control system, it was hard to convince ourselves to work on the same class at the same time, because there would be a lot of overlap, and having to do merge conflicts with a system that we aren't familiar with isn't really that enjoyable. So we opted to rather wait until the code was in a place where we could modify separate pieces. And so I think not only doing a little bit more game design would be helpful at the beginning, but also some code design would be helpful. So I think if we were to do this, since we did this in, I think, 4 weekends, I think we could probably take one weekend to completely, like, just pen and paper, almost no coding, and just come up with a design for a game and come up with a general code layout for the game, and then iterate off of that for the remaining weeks would be worthwhile, I think. And otherwise, I really think that it was cool to be able to write with such reckless abandon, and be able to write if statements that do the exact same thing inside of them for 4 different times, because that's not something I'm allowed to do at work. And fast iteration feels good, even if it's kind of quick and dirty. I think if there's little risk of quick and dirty biting you in the end. It's not a serious project. It's totally worth it to just go as fast as possible and get the main concepts out of the way and not really worry too much about code quality. I think it's not really that worthwhile at the outset.
Yeah, I agree. Especially with the code quality thing, I think that over optimizing in the beginning when it doesn't really matter, you're really the game design part is the most important, and that's something that I put in my important takeaways list as well.
Yeah.
Is that the prototyping is really important. So you sent me a link the other day about a Steam game thing that it's sort of half game, half not IDE, but sort of like an IDE that's more than an IDE. It's almost like a gamified IDE where you can. It kind of reminds me of Game Maker, but a lot more dumbed down.
Yeah,
where you can just drag and drop models and then program
builder thing.
Yeah, it's like a game builder. But I think even using something like that, or maybe just starting off really stupid simple, not even programming like you were saying, maybe just trying to get a feel for it with pen and paper or with the least amount of work possible, and being able to iterate quickly on that is really valuable because, like you were saying, we learned very quickly that, okay, well, the tile updates, it's all cool and stuff, but it's not fun at all.
Yeah.
I think that the turn-based game would be more fun, but at that point we're already done with this thing. We don't really want to work on the turn-based thing. It is a lot more fun, and it would have been more interesting if we had that vision in the beginning.
Yeah.
Or if we were more if we were passionate about this project or something, but we're not. So we just cared about learning and enough that we can use what we learned in the future. Maybe not even in the next project, but in the future. We make it fun. And what do we do? How do we define fun? Maybe we set a goal in the beginning. But it's a hard thing to. It's like, what is happiness? You know.
Yeah, and with that, good night. I would say let's make the next one an actual game.
Sounds good.
Not something that is a programming exercise that kind of ends up a game.
Right, exactly. Yeah. Cool. So with that, I think
subscribe. I have a list of the Patreon subscribers that I will now read out of the highest tier of Patreon. All right, that's it. Thanks. Good night.